So far, we've been just looking at the relationship between pressure, volume, and temperature. When one increases or decreases, what happens to the other related variable as long as the third one is held constant. So this week, our math application is to now just convert between pressure, volume, and temperature units to prepare us for next week when we start doing actual calculations. So we're just going to kind of practice playing with the different units and converting between them for each of these variables. So as we've talked about before, P represents pressure, which is, we've said, force, and our different units for pressure, we're going to describe all of these at atmospheric pressure because they are all proportional to one another at atmospheric pressure by these values. So 1 atmosphere, we've already talked about that, 101.3 kilopascals, 760 torr, 760 millimeters of mercury. Torr and millimeters of mercury are basically the same thing, just a different unit. And 14.7 psi. So there's all of our different units of pressure at atmospheric pressure. And like I said, they're all proportional to one another, so these can all be used interchangeably as conversion factors. So if I wanted to know how many kilopascals are in 1 atmosphere, I could use this relationship as a conversion factor to convert between the two units. That will be helpful for all of our problems today. Next, V represents volume, which is the space the gas takes up. A couple of helpful volume conversions. We've got 1,000 milliliters in 1 liter. Of course, you can always set up a conversion, but if you're given milliliters, a quick way to just convert between milliliters and liters is to move that decimal, like we talked about at the beginning of the year. To go from milliliters to liters, you would move it three times to the left. And again, if that is not very clear to you, set up a conversion factor and use this relationship as that conversion. Then we have 1 milliliter is equal to 1 centimeter cubed. So they're essentially the same unit, but measuring, or the same value measuring different units. And our third variable is temperature, which we just learned is the measure of kinetic energy. We often call that heat. I'm going to specify to kinetic energy. When we do temperature calculations, these always need to be converted into Kelvin for our calculations. I think there's one on here that has you, just for exercise sake, convert to Celsius. But next week, every single temperature value needs to be in Kelvin, and moving forward whenever we do a gas law problem. So always, always, always convert to Kelvin. It's very easy. All you need to do is add 273 degrees and you will be in Kelvin. Okay, so 273 puts you in Kelvin. And for the sake of exercise, if you are given Kelvin and need to go back to degrees Celsius, you'll subtract 273. Makes sense mathematically to get back and forth between the two. So just like I said, for today's work, we're just going to be converting units. So you'll need to take a look at each of the units and then decide, is it pressure, volume, temperature, and how can I convert between them? I would suggest starting with any pressure values and doing a conversion, because that one's going to take a conversion factor. And then the remaining variables, you can either do a quick conversion factor using the volume and liters if necessary, or you can just move that decimal. And then temperature, you won't need a conversion factor. You'll just need to do some subtraction or addition. Let's start with pressure. So I have my pressure values. My given is in atmospheres. And I'm finding kilopascals. So let's set up a little train track conversion here. And from our relationships above, we know that 1 atmosphere is equal to 101.3 kPa. Okay, so there's my pressure conversion. So for pressure over here, I'm going to have two answers, one for pressure and one for temperature. So put this in your calculator and you get 436 kilopascals. So there's our pressure in the new unit. And then to find our temperature, you're just going to take your degrees Celsius and add 273. So for temperature, our Kelvin will end up being 298 Kelvin. I've said this before, but 25 degrees Celsius is room temperature, so this is a helpful little conversion to remember. 298 is room temperature at, or in Kelvin for our unit of temperature. And again, I'm just going to make a note here, always use Kelvin in gas law calculations. This will be for next week, the importance of using Kelvin. So that's the process for each of these. Let's do one more that involves volume, just so you can see how we're going to do that. Again, I would suggest using the given find workspace for any pressure conversions, and then do the other one. So here's pressure. Just identify those units. 953 millimeters of mercury, and we're finding atmospheres. So do a conversion. Back at our relationships here, we've got 760 is equal to 1. So that'll be our conversion factor here. Plug it in. And you get 1.25 atmospheres of pressure. Now we have one other variable, volume. I'm going to underline these two. So we're going milliliters to liters. You could move the decimal point, but I'm going to set up a conversion for the sake of exercise. So we got milliliter, 1,000 milliliters is 1 liter. So divide by 1,000, that's the same as moving our decimal 3 times to the right, which is why we can do that shortcut. So our volume will be 0.535 liters of gas. And this is why. So anytime you have milliliters that you're changing into liters, feel free to just change it into a decimal real quick by moving it 3 times to the left, and you're good to go. Okay, so you continue your work on page 11 and 12 for today using those relationships in units.